Welcome. This is video number 415, and in this video I am going to show how to fit and interpret Poisson regression model in Stata. Here is my model. Yi is the dependent variable, but this time it's a count variable. Here our dependent variable is household size, that is number of people living in a household. One of the independent variable is age, which is a scale or numeric or continuous explanatory variable. I have one categorical independent variable race. It has three categories, so I have included two dummy variables for this. D1 is equal to 1 if the person's race is black, 0 otherwise. D2 is equal to 1 if the person's race is other than black and white, 0 otherwise. Both D1 and D2 are equal to 0 if the person's race is white. And the total number of people who have participated in this video is 10,351. In order to fit and interpret Poisson regression model, I'll go to my data file. Here is my data file. And as I told you, in Poisson regression model, the dependent variable is a count variable. So household is my count variable, and age is my continuous independent variable, and race is my categorical independent variable. So let me go to count and Poisson, and here in this I will delete all this data which I have put it here. So let me put household size as my dependent variable, and this is count, because the number of people living in one household is just like a count data. I will put some variable here. So age is my first variable, since this is continuous. So I will add it here, but before that I will delete this model. So I will add to var list, and after this I will submit. Now this is the first estimation of my Poisson regression. The command is Poisson house size age, and here this is just like odd ratio. So this is the coefficient for age, and this is the coefficient for constant. Now let me put another variable, and that is race. And since race is a categorical variable, so I am not going to check this box. I will add to this and OK, and after it I will submit. Now this is my estimation for this is the main effect of age, and this is the main effect of age. So this coefficient is for the black, this coefficient is for the other, and the base category is for the white. Now I will include the interaction effect. So I'll go back here, and this time I will click on this and I will select interaction 2A. Here I will give age as my continuous variable. I will leave this, and I'll also add race to this. Since this is categorical, so I'm not gonna check this. I will add this. So if I submit, this is my estimated model. So this is age, this is main effect of race. One is base category, this is for black, and this is for other. White is the base category here, and this is the interaction between age and race. Since these coefficients are a bit tricky and difficult to interpret, so for that purpose I'll go to post estimation, and here I'll click on this and I'll launch this, and after launching I will yes, this covariate is race, and here it should be age. So let me delete this because this was added earlier. So my first covariate is race, and here since I am using the interaction coefficient or the interaction factor, so I'll give it age, and here I will specify uh, categories of age. So I'm telling Stata to give me marginal predictions of age groups from age of 30 to 8 years of age with interval of 15. And if I submit, these are various uh, marginal predictions. Now, before I explain this, let me look at the command. This is my command margins, race at age from 30 to 80 with interval of 15. This is the uh, total number of observations, and these are the various expression 8. So 1 represents age 30, 2 represents age 45, 3 represents age 60, and 4 represents age 75. Now, what does this mean? This is the marginal prediction of someone who is 30 years of age, and he belongs to white race. Then in his household there are about 3 persons. And this is the marginal prediction, the marginal predicted number of members in a household for someone who is 30 years of age and he belongs to black race. This is almost 4. So this is 3. We will round off this as 3, and this will be rounded out as 4. Similarly, for someone who is 30 years of age and he belongs to other race other than black and other than white, and the marginal expected number of people in that household will be 4. And similarly here, for someone who is 75 years of age and he belongs to white race, on the average the expected number of household members for that particular individual is 2. Same for black, and but for other race at age 75, the expected marginal predicted number of persons in a household for a person with other race is 4. So these are the interpretation of various marginal predictions for the various interaction between the age and the race. Let me also show you the plot, profile plots. I will launch this, and after this I'll give at age, and here I'll give race, and here I am asking this data do not plot confidence interval, so confidence interval will not be there. So if I submit, here is my graph. Now, how to interpret this? This blue color means that the individual belongs to white race. This maroon color means that the individual belongs to black, and this green means that this particular individual is neither belonging to black nor to white race. So for both black and white people, the marginal predicted number of individuals in household going to decrease with age. At age 30, for white, this is the marginal predicted number of members in a household. And for black, at age 30, this is the marginal predicted number of household members. And finally, at age 75, this is the expected are predicted number of individuals in a household for a white person, and this is the marginal expected number of individuals in a household for black. So it means for both white and black people, the marginal predicted number of household members going to decrease with age. So these are negatively sloped. But as far as the other race is concerned, which is neither black nor white, this is almost constant. And at all ages, that is at age 30, at age 45, and age 60, and age 75, more or less the marginal predicted number of individuals in the household are almost the same. There is no big change in that. So this is how we estimate, interpret marginal predicted numbers of the events in Poisson regression. I hope this was of help to you. If you have any problem with this, kindly do ask me in the below comments, and I'll get back to you with the possible answer. I thank you very much for watching this video. So here is my, if you haven't yet subscribed to the channel, kindly do subscribe, and do not forget to click on the bell icon so that you can get notification about other videos that I'll upload for you. Thanks for watching this video. Kindly share this channel and the various videos with your students, with your colleagues, with your friends, and in various WhatsApp groups, so that this channel could reach to the maximum number of people. So I thank you a lot for watching this.